Galaxy is mentioned a lot in astronomy, but what exactly is a galaxy? A galaxy is a large collection of gas, dust, and billions of stars, and their solar systems. Each galaxy is held together by gravity and force that attracts lighter objects to the heavier objects around. And by no surprise, this applies to every single galaxy, including the Milky Way, the galaxy where our Earth is located. In the Milky Way, there's like a massive black hole at the heart. But before we tell you more about a specific black hole, let's learn about the general information of black holes. In 1783, a physicist who goes by the name of Michel suggested that the existence of black holes is real. But of course, he didn't call them black holes, he used to call them dark stars. This concept is based on Newton's law of gravity and escape velocity. The law of gravitation states that two bodies in space pull on each other with a force proportional to their masses and the distance between them. And escape velocity is the minimum velocity that a moving body must have to escape from the gravitational field of celestial body and moving outward into space. Laplace, a scientist, asked himself if there's an object which could have enough mass to attract everything to it. This idea was based on Michel's hypothesis, but of course, no one believed in the existence of these terrifying objects back then. So in his defense, he explained that we could prove the existence of terrifying, invisible objects by observing other stars. The star may orbit around such objects and reveal their existence. Around 1930, theorists who used Einstein's theory of gravity, which is also known as general relativity, showed that massive stars could collapse under their own gravity at the end of their life and turn into black holes, even though Einstein's theory was one of the factors proving that the existence of black holes is real. He himself didn't believe that such objects exist. The second claim that Michel made was confirmed in the early 1970s. Louis Webster and Paul Merton, who were both astronomers, announced the discovery of a massive invisible object in orbit around a blue star over 6,000 light years away. The object name was Cygnus X1, also known as the first black hole in the history of mankind to ever be identified. As we now know the general information regarding black holes, let's move on to the Sagittarius A, the black holes that lies through the heart of the Milky Way. Sagittarius A was discovered in 13th of February 1974. Bruce Bailey and Robert Brown, who were both astronomers, pointed radio telescope in Green Bank, tower of the center of the Milky Way. They saw a dim speck and suspected that it was the central black hole of our galaxy. They found it in a slice of sky that is known as Sagittarius A, which is located within the constellation Sagittarius. The astronomers then named the black hole after its location, which is why it is called Sagittarius A. For the next 2 decades, radio astronomers tried to see more views of Sagittarius A, though they were limited by a lack of suitable telescopes. Sagittarius A is cancelled by a veil that is multi-layered. The first layer is called galactic plane. It contains 27,000 light-years worth of stars, gas, and dust that blocks light. Luckily, radio waves were able to sail through the galactic plane, but it wasn't that easy when they reached the second layer, the scattering screen. It is a turbulent patch of space where density variation in the interstellar medium knock radio wave occurs by some bit. The third and the final layer covering Sagittarius A is the infalling matter surrounding the black hole. The outer layers of matter emit longer wavelength light, which is the same wavelength VLBI works with VLBI that works with shorter wavelength light, would make it easier to see close-up views of the black hole's even horizon, but it wasn't considered a major technological challenge. Astronomers who used other techniques were most successful, gathering indirect evidence that Sagittarius A speck was actually a seething supermassive black hole. In the 1980s, Charles, who is a physicist, and his colleague showed that gas clouds in the galactic center were moving in eccentric ways. The certain ways to the question would only make sense if they were caused by some great invisible gravitating mass in the 1990s. Gus and Jensel began tracking the orbits of giant blue stars in the galaxy center, mapping their motion around heavy yet unseen pivot points. As time went on, the situation for radio astronomers eventually improved. In the late 1990s and early 2000s, a new generation of short-wavelength radio telescopes started to come online. It's a type of telescope that could participate in VLBI observations at a microwave frequency, thought to shine from the edge of Sagittarius A shadows as long as it augments with bespoke equipment. At the same time, being the computing revolution that led to solid-state hard drive and smartphone in every pocket notably increased the amount of data that each observatory in network of radio telescope could record and process. Around 2007, a small precursor to the EHT used the telescope in Hawaii, California, and Arizona to pierce the veil covering Sagittarius A. The result wasn't a perfect piece of image, but the project noted something, presumably light from the Log-Saw shadow. Several years later, after growing into collaboration that includes more than 200 scientists with 8 participating observations across the globe, the EHT took its first successful shoot of Sagittarius A shadow. Over the course of 10 days, in April 2017, telescopes in North America, South America, Hawaii, Europe, and Antarctica zoomed in on galactic center and some other black holes, gathering 65-hour worth of data on 1,024 8TB hard drives. 5 years after that, EHT researchers showed the world that their experiment worked. On the day, EHT collaboration reviewed images of Sagittarius A. The Astrophysical Journal Letters published a special issue dedicated to the new results. The images of Sagittarius A confirm many information of it.